Okay, this is how we are going to demonstrate to you how to evaluate or assess whether your data are normally distributed. So you can open up the file that I've given to you, titled Hours Serving Internet Per Week Normality Check .sav dataset 1. Okay, so to do this, it's very simple. So the basic assumption that we had just now, these are the 30 different students, and this is the independent variable. The students are the student identity is the independent variable, and the hours surfing the internet um, as the dependent variable. Okay, so we are going to check the data, whether the data are normally distributed. To check it, very easy. You click Analyze, you go to Descriptive Statistic, okay, and then you go to Explore. Okay, then transfer your dependent list. The dependent list is the total hours serving in the dependent list. Okay, it doesn't matter whether you transfer or not student to factor list, but I don't do that. So just check, click statistic. You can see if you require descriptive statistic like mean, standard deviation, and stuff. Importantly, you have to click plots. All right. Here you can see the box plots, the descriptive, and the normality plots with test. Very important to click normality plots with test, because this is where you can get your Kolmogorov, Smirnov, Shafir-Wick, kurtosis, and skewness. If you want to see this visual representation of the data, you can click stem and leaf and histogram. Okay, so we just have a look at the both side first, but I don't normally do this. I usually do not take descriptive, because I just depend on values of the Kolmogorov, Smirnov, and Shafir-Wick. So you can click continue and then click OK. Right, so this is the output 1 document. Wait for a while for the computer to compute. Right, so these are the outcomes of the analysis. Look at table case processing summary. You can see that all the entry were analyzed. Okay, so there is no missing data, which is very good. We do not want any missing data in our analysis. So the computer is actually computing all the entry that we incorporated. Okay, then you can look at this descriptive table. You can see that all the different confidence interval, median, okay, standard deviation. Range here is not like minimum and maximum. So for IBM SPSS, for some reason, this is not the range that we are looking at. So if you want to report the range, it will be the minimum to maximum. So minimum is 10 hours, the maximum is 25 hours, right? Then you look at the interquartile range. This is very useful. If the data are not normally distributed, you are going to report the interquartile range. Look at kurtosis and skewness. Skewness is 0.067, so this is nearing zero, which is good. This is an indicative indication that the data can be normally distributed. Kurtosis is also negative, which is good. This is nearing zero. So look at test of normality, Kolmogorov, Smirnov, and Shafir-Wick. The p-value reported by Kolmogorov, Smirnov is 0.20, above 0.05. That is good. That shows the data are normally distributed. Shafir-Wick also agrees to that. The value is 0.296. Okay, but considering that the sample size in this exercise is small, it's only 30, so you have to depend more on Shafir-Wick values rather than Kolmogorov, Smirnov value. Of course, in this example, both agree to each other, but when there are instances whereby these two are not, then if the sample size is lesser than 100, you have to rely on Shafir-Wick and vice versa. Look at the histogram. So this is what I meant by it doesn't really look like the data are normally distributed. So it can be confusing to some people. So that's why I prefer values like this rather than visual representation. This is histogram, and then you can look at the stem and leaf. Of course, you can see a little bit of normal distribution here. You can see the majority of distribution is actually at 6. At 1.8, 1.8, 1.9, 0.9. So there are 6 individuals. okay, um, 18, 19 hours, okay, right? So that's how we check whether the data are normally distributed or otherwise. So that's it.